Hey, did you just fall? No, I was checking if gravity still works. See, falling down is not a problem, but how you are reacting for it will tells everything about it. Similar way, when you're opening your book to solve the problems, if you think that all this are just numbers and they are threatening you, obviously you will feel the same. Just change that thought. Sometimes you may feel solving problem is like watching a movie of unknown language without the subtitles. God is really creative. So when you are trying to give a try, you will get that awesome feeling that finally I got this. Yeah, me neither knows to solve it. Right? Let us get into the class to get that feel now. Five point one. Give the magnitude and direction of the net force acting on the raindrop falling with the constant speed. The word constant speed represents that the acceleration of that is zero. So net force obviously zero according to the Newton's second law of motion, that is F is equal to ma. Second part of the question. A cork of mass 10 kg floating on water. Whenever an object is going to float on any of the fluid, we know that it will be having two forces acting on that. One is the weight of the object, the other one is the upthrust. Both of them will be equal and opposite in magnitude, so the net force acting on that will become zero, which means that there is no net forces acting on the floating cork. Right? Third part of the question. A kite skillfully held stationary in the sky. The word stationary means the object is going to be at rest. If an object wants to be at rest, we know that there is no external forces acting on it according to the first law of motion. So the net force acting on the kite must be zero, then only it will be at rest. That means that it will be stationary. Fourth part of this question. A car moving with constant velocity 30 km per hour on a rough road. Once again, the word constant speed represents that there is no acceleration, because acceleration is change in velocity over time. So acceleration is zero according to Newton's second law of motion. F is equal to ma. That is also zero. So it's zero. Now we are considering an electron which is going to be in a free field, which means that it's not going to get affected by any of the other forces like electrostatic force of attraction or magnetic field. So it is obvious that the net force acting on the electron is also zero. Question number 5.2. A pebble of mass 0.05 kg is thrown vertically upward given the direction and magnitude of the net force on the pebble. So we have four cases here. The first case, the upward motion of the pebble, we have to calculate the net force. Second one, downward motion. Then the third one, at the highest position when it's at rest. When it's going to come for the fourth one, the same pebble is thrown at an angle of 45 degree what is the net force acting on this pebble? In all these cases, if you are going to notice, the common force which is going to act on the pebble, that is the stone, is the gravity. We all know this very well, that gravitational force will always act towards the downward direction. So irrespective of in which direction the object travels, upward, downward, or it's at the highest position or the angle, the gravity will always act towards the downward direction. So the acceleration of the object is going to be acceleration due to gravity only. Only the gravity will act in all the three cases. When it's going to come for Newton's second law of motion, F is equal to ma. Here the mass is going to be 0.05 kilogram and acceleration due to gravity is 9.8. So the net force acting on the pebble, that is the stone, is 0.49 Newton in all the cases, even at 45-degree angle also. Question number 5.3. Give the magnitude and direction of the net force acting on a stone of mass 0.1 kilogram. We'll be having 4 different situations where this 0.1 kilogram is going to be dropped out of the train. In the first case, just after it is dropped from the window of a stationary train. So we are going to drop it out of a stationary train. Just if you are going to notice it, the train is at rest and the stone or the ball is being dropped towards the downward. So the only force which could able to act on that ball is nothing but the gravity. We know the mass, and the weight of the object is going to be the one what we are saying as the amount of gravity acting on it. Weight will be given by mg and g is 10 meter per second square. So we are getting the force acting on the ball as 1 Newton, which is in the same direction as the gravity, so downward. In the second case, the train is going to move with the velocity of 36 km per hour, constant velocity, and the ball is being dropped. So just it is dropped from the window. That means that if the train is going to move in the forward also, the ball or the mass 0.1 kg is going to move towards downward with the gravity only. So it is not going to get affected by the train's velocity. So here also the net force acting on that will be given by weight, which is nothing but 1 Newton. When it comes for the third step over here, just after it is dropped from the window, a train accelerating 1 meter per second. Further, the speed of the train got increased, but we are talking about the mass which is dropped through the window. So once again, if you're going to notice that as the train move forwards, the ball is going to be dropped down, but the train is going to have a higher acceleration compared to the ball what has been dropped, because its velocity got increased now. So when we are trying to notice the ball and the movement of that, as it dropped down from the window, it is going to work or move based on the acceleration due to gravity only. So it will try to move in a horizontal direction, but when it is going to be dropped, it will go along with the gravity only. So here also the force will be the weight of the mass, which is 1 Newton. Again it will be downward. When it's going to come for the fourth case, the person is lying on the floor of the train and the train is accelerating 1 meter per second square. Now we are going to consider the same ball. The ball is going to be dropped down or it is going to be at rest. Now when the ball, if you are going to look at it, it will be having a weight and it is on train which is moving. Here the weight of the ball and the normal reaction force of the train, both of them will be balanced. So the net force felt by this mass will be equal to the mass force of the train, that is 0.1 into 1, which is of 0.1 Newton, which is of the same as the train over here. Question number 5.4. One end of the string of length L is connected to a particle of mass m and the other to a small peg on a smooth horizontal table. If the particle moves in a circle with the speed of v, then the net force on the particle is. We have to find it. Which of the following will be the answer? When we are considering a peg, it's like a hook is being tied with the thread and it's going to be placed on a circular table which we are going to revolve, right? So when it's going to come for the peg is a kind of mass which is attached with the thread over here, which is going to move with the velocity v in the circular path. When we consider a rubber band which is tied with the mass at its one end and you're going to rotate it in a circular path with the help of your hand, you will be able to feel that the ball is going to be pulled towards the inward, or the rubber band will be stretched out of its length as you're going to rotate it, right? That's the same kind of elastic restoring force will act on the thread over here as well. That restoring force only we are calling over here as the tensional force. So when we are trying to rotate it, the peg will try to move out of the circle, but this restoring force, that is the tensional force acting on the thread, trying to pull it inward of this center of the table. That means that this tensional force is going to be equivalent to the centripetal force, which allows the object to move into the circle, which means that tension is going to be equivalent to the centripetal force, which allows the object to be revolving in the circle. So that the net force, what we are going to consider over here, will be equal to the tension only as per the case over here. Question number 5.5. A constant retarding force of 15 Newton is applied to a body of mass 20 kg moving initially with the speed of 15 meter per second. How long does the body take to stop? So we are noticing over here there is a force acting, but it is a retarding force. Retarding force is the force which will oppose the movement of the body, so it's taken as negative over here. And mass of the body is 20 kg with the speed 15 meter per second. That means that is our initial speed. Now we have to find how long does the body take to stop. That means that we have to find the time. For that we need the final velocity. The hint over there is body is going to stop. So final velocity is 0. The force we know, which is of minus 15 Newton. Initial velocity we know, and the mass also we know, the final velocity also we know. So when I'm trying to find it, force is equal to mass into acceleration. So 50 is equal to 20 into A, which is a mass and the force. Here the minus represents the retarding force over 20, which gives us the acceleration of minus 2.5 meter per second. We want the time now. So the final velocity, initial velocity, acceleration and time can be connected with the first equation of motion. V is equal to U plus AT. We are just rearranging the equation here so that T is equal to minus U by A, because our V is 0 here, where the value of the U is going to be 15 and the value of the A is going to be minus 2.5. So minus minus will get cancelled. So 15 over 2.5 is going to give us the answer as 6 seconds. So the body will take 6 seconds to stop. Question number 5.6. A constant force acting on a body of mass 3 kg changes its speed from 2 to 3.5 meter per second in 25 seconds. The direction of the motion of the body remains unchanged. What is the magnitude of the direction of the force? So the mass given here is 3 kg and the initial velocity is 2 meter per second. Final velocity is 3.5 meter per second, and it is going to happen, the change in speed is going to happen within 25 seconds. Now we wanted to find the magnitude and the direction of the force when it's going to change its speed from 2 to 3.5 meter per second. But remember, the direction is going to remain unchanged. By using the first equation of motion, we can find the acceleration of the object, that is V is equal to U plus AT, or A is equal to V minus U by T. So the V and U we know, the time we know. By substituting it, we can get the answer for that as 0.06 meter per second square. As per the Newton's second law, we know that the force can be calculated by mass into acceleration. For the corresponding change, what is the acceleration we got? So that we are just substituting it over here and we are getting the answer as 0.19 Newton. We got the magnitude. Now when we are finding the direction, the application of the force does not change the direction of the body. It's mentioned in the question. So the body remains in the same direction, shows that the net force will be in the same direction. Question number 5.7. A body of mass 5 kg is acted upon by two perpendicular forces 8 Newton and 6 Newton. Give the magnitude and direction and acceleration of the body. Here two forces are acting. One is 6 Newton, the other one is 8 Newton, about the mass 5 kg, and they are acting perpendicular to each other. That is, the angle between these two force vectors are going to be of 90 degree. We have to find the magnitude, that is the number value and the direction of the force as well as the acceleration of the body as a result of this resultant force. That means that we have to find the resultant force. The resultant force of any two vectors will be given by the formula root of a square plus b square plus 2ab cos theta. Here our a is going to be 8, b is going to be 6. So we have substituted the same thing over here, where the cos 90 is 0. So that will, the whole term 2, 8, 6, cos 90, all of them will become 0. 8 8s are 64, 6 6 are 36. The answer is 100. Root of 100 is 10 Newton. So the resultant force magnitude is 10 Newton. We wanted to find the direction. The direction of the resultant of any two vectors will be given by the formula theta is equal to tan inverse of b sin theta divided by a plus b cos theta. We are using the same thing over here, so that we are getting the value of the tan theta as 6 over 8, or tan inverse of 6 over 8 is going to be 36.87. So we found the magnitude and the direction of the resultant force as 10 Newton along the angle of 36.87 degree. Now, according to the Newton's second law of motion, the acceleration will be given by force is equal to mass into acceleration, or acceleration is equal to force over mass, where the force we found over here, the resultant force 10 Newton, and the mass of the body is 5 kilogram. So acceleration is equal to 10 over 5. By simplifying that, we will be getting the answer over here as 2 meter per second square, right? So this is what is the acceleration with which the resultant force is going to act. Question number 5.8. The driver of the three-wheeler moving with the speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to rest in 4.0 seconds with the time to save the child. What is the average retarding force on the vehicle? The mass of the three-wheeler is 400 kg and the driver is of 65 kg. So the given in the question is that the driver sees a child who's standing in the middle of the road and he was traveling with the speed, that is, he started his vehicle with the speed of 36 km per hour. To not to hit the child, he is just applying the brake, which means that the force what is going to experienced by his vehicle is going to be the retarding force. That is, it's going to stop the vehicle, right? The mass of the vehicle is 400 kilogram and the driver is 65 kg. We need to go for the solution where we can find the retarding force. So the total mass is 400 plus 65, 465 kilogram, and the acceleration can be found by change in velocity over time, where in the final case object comes to rest so that the final velocity is 0. When we are coming for the initial velocity, that is given as 36 km per hour, if we are converting that into meter per second, that will be of 10 meter per second. So the u is being substituted with the value of 10 meter per second over here, and the time is given in the question as 4 seconds. So it's going to be of minus 2.5. Minus represents the three-wheeler retarding. According to Newton's second law of motion, F is equal to ma. The mass, total mass is 465, and the retarding acceleration we found over here is minus 2.5 meter per second square. So that's what's the same thing we are substituting over here, which gives us the solution as minus 1162.5 Newton. The negative sign indicates that the force is acting against the direction of the three-wheeler in order to stop it to rescue the child on the road. Question number 5.9. A racket with a lift of mass 20,000 kg is blasted upward with an initial acceleration 5 meter per second. Calculate the initial thrust of the blast. The lift of mass 20,000 kg represents the amount of energy which is going to be given out by the mass what we have over here, and the acceleration of that is also being given. If you're trying to understand the concept over here, the amount of force given by the racket mass towards the downward will be receiving the equal amount of reaction force given by the earth as well. So when we are trying to find out the net force with which the racket moves in the forward, that is which we wanted to find in the question as thrust, that is F, but that is going to be the net force due to the weight of the racket as well. So the net force F is going to be balanced by the weight of the racket as well, so that the acceleration of the racket is going to be given by the accelerating force. F minus mg is equal to ma. We are taking the mg on the other side, so m into g plus a, where the g value is 10 and a value is 5 meter per second over there, and the mass is given in the question as 20,000 kilogram over here. By simplifying that, we got the net force with which the racket moves upward as 3 into 10 power 5 Newton. Question number 5.10. A body of mass 0.40 kilogram moving initially with the speed of 10 meter per second towards the north with a constant force of 8 Newton directed towards south for 30 seconds. For instant, the force applied at t equal to 0, the position of the body at that instant is x is equal to 0, then we have to predict t is equal to minus 5 second, 25 second and 100 second. What will be the position? We are considering the mass of 0.4 kilogram moving towards the north with 10 meter per second. And there is an opposite force is going to act on this towards the south side of 8 Newton. That means that at this time we have to start it. So time is equal to 0. Then that should be taken as the starting position, which is x is equal to 0 as well. So when we are considering this case over here, for the 30 seconds, what will be the moment? For the first minus 5 second, what will be? And for 100 second, what will be? We have to find. If you are going to look at it over here, the first minus 5 second, if you are considering, for that the acceleration will be 0 because we are considering the position of the time over here from t equal to 0. So the minus 5 second is going to appear before the t over here. That means that the object was at rest, acceleration is 0 and the initial velocity is going to be 10 meter per second with which it started. So by substituting that in the second equation of motion, we are getting the answer for that as minus 50 meter. And when it's come for the second case, at 25 seconds, we wanted to know the distance. The acceleration can be found by mass over mass and force. So force is equal to mass into acceleration. Acceleration is equal to force over mass, which is minus 20 meter per second. And we are substituting the value in the second equation, which gives us minus 6000 meter for the 25 seconds. That is for first 30 seconds. And we are going to find it from 0 to 30 seconds now, where the acceleration of that we found as minus 20 meter per second squared, and the time is going to be of 30 to 100. That is around the 70 seconds we are going to find. For both of them, what is the distance we have? We can add it and we can get the answer for it. So the net distance will be given by S1 plus S2. We are going to consider the first 30 seconds over here now. So the same thing only we are going to do. Acceleration we have, initial velocity we have, so that we will substitute it in the second equation of motion, which is going to give us the value of that as minus 8700 meter for the first 30 seconds. Now by using the first equation of motion, we can find the final velocity of that, so that you could able to find the acceleration for the next 70 seconds, that is from 30 to 100. So we are finding the final velocity over here, which is of minus 590 meter per second. What is the force we supplied? For that we got it over here. Now that is for the second part. The minus 590 meter square is going to be the initial speed, and the acceleration of that is going to be 0. Time duration is 30 to 100, which is of 70 seconds. So the distance will be given by v into t. That means that the object is going to stop accelerating. That means that it's going to have a uniform motion associated with that. So it's going to be given by minus 41,300 meter over here for the 30 to 100 second. When we are finding the net displacement over here, that will be given by S1 plus S2, so that the S1 what we found already is of the value what we are going to have here as minus 8700 plus 41,300 equal to minus 50,000 meters.